Good afternoon. It's officially afternoon, and I'm feeling a little better today. I hope you guys are doing okay. So we're going to continue with our vectors, and we're going to start our word problems today. I wanted to go over the two homework problems. The first one, everybody got number 3. Number 9, though, remember we want it to be tip to tail. So we want to find, here is our tip to tail vectors, and so this vector right here is our resultant. Okay, so it's 15 units long. Now this 53 degrees is like a negative 53 if you think of it that way, kind of opening clockwise, but we want the angle that's opening all the way around. If you think about putting your X and Y axes here, you can tell it's in quadrant 4. So 53 degrees is not an appropriate answer. You have to do 360 minus 53, because that would complete the full circle if you added the 53 all the way around. So if we just subtract that 53, that gives us that amount. So that's how I got 307. All right, so just be clear that the resultant is the one that's not the tip to tail. Okay. All right, we're going to do some problems where the pictures are already drawn for us, and then you're going to try one where it's not. But y'all, after you see the two examples, I'm going to do here, you'll see that they're pretty much worked exactly the same. Okay, so let's read these and try them. It says, vector u has a magnitude of 20 units, whatever that might be, and a direction of 0. So do y'all understand the reason it's perfectly horizontal is because of that 0 degrees. It hasn't opened up at all from the horizontal. So this is our vector u. Vector v, that's this one, has a magnitude of 40, so its length is 40 units and a direction of 60. So the 60 degrees is, this amount. Find the magnitude and direction of the resultant. So we want to find both magnitude and direction to the nearest whole number. Okay. All right, so the first thing we need to start with is, are these vectors tip to tail? And the answer is no. Now, why do we not put them tip to tail to begin with? And the reason is because when we're opening up 60 degrees, it's so easy to draw it like this originally, okay? Because you can see clearly that 60 degrees opening up. However, it's not tip to tail, so we cannot draw our resultant. So what we must do is we must slide the V this way. Okay, so now that's not the only right answer. There's multiple ways to do it, but I think that's the easiest. So I'm going to redraw this. I'm going to leave my 20 going here. And then I'm going to do my best to keep the 60 degrees, to keep it parallel, and to keep my 40 units here. Now they're tip to tail, and I can draw my resultant. But what moved also when I moved the 40? Well, this 60 degrees moved as well, right? So the 60 moved, and the 40 moved, and the vector itself moved. So where is the 60 located? Well, it's in the same relation that it was to the 40. So here, the vector, is here, and the 60 should be to the right of it. So we're going to make a dotted line, and our 60 degrees is going to go here. Okay? Now I'm going to draw my resultant in bright blue. So that's my u plus v, or my resultant. And now it's asking us for this magnitude, which is the length, and then the direction. How many degrees? So we're looking for this theta. How many degrees does it open up? And we're looking for this side length. Oh goodness, excuse me, my hand slipped. How long this vector is. Okay? So, how do we do that? Well, I guess the first question is we need to think back in our brain things that we've learned before with triangles to find sides and angles. So you might be racking your brain, you might be thinking SOHCAHTOA, but SOHCAHTOA can only be used when we have what kind of triangle? Right triangles. So this is not a right triangle. So what have we learned in this class that we use when we don't have right triangles? So we have learned the law of sines and the law of cosines. These are very helpful formulas for quote-unquote real-world problems, because not everything is going to be a perfect right triangle. So my question is, which one do we use? If you remember, law of sines was angle, side, angle, 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 side, and then the bad word backwards. Okay? And then law of sine was side, angle, side, and side, side, side. So what do we have here? Well, we have a side, and now technically this 60 is not in our triangle. So the 60 though will help us find this angle right here, and that's because this angle and this angle make a linear pair, which means 180 degrees. So if this amount is 60, then we can find this amount. So this angle here, we're just going to do 180 minus 60 degrees. So that gives us 120 degrees. So you guys, that is two sides and an angle. Is the angle between them? The answer is yes. So we're going to be doing the law of cosine. Okay? So now, what should we find first? Should we find the side, length, or the angle? And if you remember from our previous unit, it's much easier to find the side first. So we're going to call this x. Okay? Or, you know, we could call it A, but that's kind of the letters we used before. But I'm just going to leave it as x. Now, we called it x squared. Okay? Let's see if we can remember this formula. So it goes, you're going to take the two sides, so 20 squared plus 40 squared, then minus 2 times each of those numbers, and then cosine of the angle. And I would say the only thing you need to be careful of here is you're going to use the 120, not the 60. Okay? Because the 60 is there to help us find the 120, but it's not what we're using. All right, now I'm just going to type it in. I have my handheld calculator over here. So 20 squared plus 40 squared minus 2 times 20 times 40 and cosine 120. And we get x squared equals 2800 on the dot. Now, is that what our side length is? The answer is no, because we got a square root, right? So x is approximately 52.9, and it asked us to round to the whole number, so 53 units. Now that should make sense. It is the biggest side. It's across from the 120, which is going to be the biggest angle, and it's bigger than 40 and 20. So that kind of seems to make sense. Now we want to find our theta. So we're still going to use cosine of theta, the law of cosines, and if you remember, we use the sides on either side of the angle first. So we're going to do 20 squared plus 53 squared, and then we minus the one that's across from it. And we put that in parentheses, and then over 2 times the first two, 20 times 53. All right, so let's type that in. So we're going to do 20 squared plus 53 squared minus 40 squared. I'm going to do it numerator. I got that, and then I'm going to do the denominator. Now I'm going to divide those, and I get 7, 5, 8, 9, 6, blah, blah, blah. And do you remember how we get rid of that? We do the inverse. So we're going to do second cosine and then put that number in there. So second cosine second negative. And so then theta is approximately 40.6 degrees or 41 degrees if we round. All right, so our magnitude, how long was the resultant? Our resultant, the answer will be, let's do it in a pink color that's bright. So our answer is 53 units at 41 degrees. There's our answer. It's our magnitude and our direction. All right, let's do another one. Sorry, I've kind of run out of space here. Okay, so it's a similar picture. We have a 0 degree vector, so it's horizontal because it's 0 degrees. So this is our U and this is our V. Okay? In order to find the resultant, we're going to have to slide one of them so that they're tip to tail. So I'm going to leave the horizontal and I'm going to slide this one. So now my 18 is here and my 70 also moves. So notice it's to the right of the 18, so it's still going to be to the right of it. Okay? I guess so I don't confuse you, let me do this. When I write the 18, I should write it over here like it was. And then the 70 is here, but it doesn't matter where that goes. Now I'm going to kind of think about scratching this out and the 70, and then I'm going to draw my resultant. Let's use green. So the resultant goes from the beginning of this one to the end of this one, and that's my u plus v, or my resultant. Okay, now the next thing I need to use is I need to find this angle here. So I'm going to do, to find that angle, I'm going to do 180 minus 70, because again, these two angles together make 180, so that should give me 110 degrees. And now I'm going to do the law of cosine to help me find this side, the magnitude of it, and then I'm going to also find this angle here, how much it opens up. Okay, so you know the angle is really this green angle from here to there. Okay. All right, so let's find x squared. Sorry, I've kind of run out of room. Maybe I'll do it above it. Okay, so let's do x squared equals 15 squared plus 18 squared minus 2 times 15 times 18 cosine of 110. Now that, if you need to go back, just go back to the videos, the YouTube videos where I did law of cosine, and that would help you. All right, so I'm just typing it in now. And I get a large number. X squared is 733.69, blah, 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 blah. I'm going to take the square root of it. And so then I get x is approximately 27 units. Okay, so 27 units. Now I can find, so that's my magnitude. So I'm going to go 27 units at, and now I got to figure out the degrees. Okay, let me scoot this over a little bit. Okay, so now let's find the angle. All right, so we're going to do cosine theta equals, remember we want to use the two sides on either side, so 27 squared plus 15. Then we're going to subtract, sorry, I'm running into this, the side that's across from it, which is the 18, over, and then 2 times those two numbers. All right, I'm going to type this all into my calculator. So 27 squared plus 15 squared minus 18 squared. And then divide by. Okay, and you should get cosine theta equals 0.77 is like repeating. Okay, and so then we're going to do second cosine second negative. And then theta is approximately 38.9 or 39 degrees. All right, so there's my answer. 27 units, that's the magnitude. 39 degrees is the direction. All right, now there is no picture for number 12, but I don't want you to get overwhelmed. It's literally the same as numbers 10 and 11. I'll go ahead and help draw it for you, and then you're going to work it. So it says, U has a magnitude of 24 in a direction of 0. So it's going to be like this, okay? Vector V has a magnitude of 40 in a direction of 115. Now, here's the thing. You could go like this and just do like we've been doing thus far. But I would be careful because that's not really drawn to scale, you know? Now, here's the thing. You'll get it right, like even if it's not drawn to scale. But let's try to draw it a little more accurately, okay? So we have the 24 here, but if it's 115 degrees, do y'all agree that's obtuse? So it should go like this, right? And then that was, what, 40 units. Okay, so that's great and all, but that doesn't help us because it's not tip to tail. So when we drag this left one to the right, it's going to be a little more dramatic like this. And then you should be able to draw your resultant. Okay, I just want it to be as accurate as possible. And And then your resultant is going to go like this. So you're going to find this and you're going to find that. And that's all I need for you to do. Okay, we'll continue with our word problems tomorrow, but I just want you to try number 12. And don't forget you're finding both things, the magnitude and the direction. Awesome. Y'all have a great day.